For example 1, I'm going to be doing problem 3. So first off, we want to factor, and so I'm going to be using the diamond method. And so negative 16 times 1 is negative 16, and then negative 6 goes on the bottom. And then we want to find what multiplies to be negative 16 and adds to be negative 6. So that's negative 8 and 2. So I'm just going to rewrite that. So next what we want to do is find the restrictions, and so we want to use the denominators and equal them to 0. So it's going to be x minus 8 equals 0 and x plus 2 equals 0. And so I'm just going to add 8 to both sides and then subtract 2 on the other side. And then what we should get is x equals 8 and x equals negative 2. And so this means that x cannot equal 8 and x cannot equal 2. And so after that, we're going to try and find the LCM. And so I'm going to be using the denominator, so x minus 8 and x plus 2, and then comma, the other denominator, which is x plus 2. And so since x plus 2 is written there twice, we can cross that out. We can cross out the other x plus 2 and have the LCM be x minus 8 and x plus 2. And so we want to make sure that both of the denominators have x minus 8 and x plus 2 in them. And so we're going to multiply the other one by x minus 8 in both the numerator and the denominator so that they all have the same denominator. What we're going to do next is combine both of the terms, and so have them all be over the same denominator, which is going to be x minus 8 and x plus 2. And so we're going to combine both of the numerators together. And then since the denominators are the same, which is x minus 8 and x plus 2, we can just write it once as the denominator. After that, we want to multiply the x plus 5 and x minus 8 together, and so I'm going to be doing an area table and having x plus 5 be on the top, and then x minus 8 be on the side, and then I'm going to multiply that out. And so when we write out the next part, I want to make sure to write it in parentheses because we still need to distribute the negative sign. So now I'm making sure I distribute the negative sign to the other terms in the parentheses. And so this means that x squared is going to be negative x squared, and negative 3x is going to be positive 3x, and negative 40 is going to be positive 40. And so now I'm going to add and subtract the like terms, so I can get rid of the x squared and the negative x squared because they cancel each other out. After adding and subtracting the numerator, I should get 3x plus 37 over x plus 2 and x minus 8. For example 2, I'm going to be doing problem C. And so first what we want to do is factor out everything that we can. And so I'm just going to start by factoring out the denominator. And so I'm going to be using the diamond method. And so 12 times 1 is 12, and that goes on top, and then negative 8 goes on the bottom. And then negative 6 and negative 2 multiplied to be 12 and add to be negative 8. Next, I'm going to factor the numerator, and so I can pull out a negative 6 from both of them and then have x minus 6 be the leftover. So have it be negative 6 times x minus 6. And then I'm going to write the newly factored denominator down there, which is going to be x minus 6 and x minus 2. I'm going to cancel out negative 6 from the numerator and the denominator, and so it's going to equal 1. And then I'm going to rewrite the problem, which is going to be negative 6 over x minus 2 equals x plus 2 over x minus 2. And so I notice that both of the denominators have x minus 2 at the bottom. So I'm going to multiply each side by x minus 2 to get rid of the denominator and leave negative 6 equals x plus 2. From there, I'm going to solve for x, and so I'm going to minus 2 from each side, and so I should get negative 8 equals x. To make sure that negative 8 does equal x, I'm going to plug in negative 8 as x in the beginning problem. $84 divided by 14 is 6, and $140 divided by 14 is 10. And so since there's a negative in the numerator and denominator, it becomes a positive. And so this statement is true, which means negative 8 does equal x. For example 3, I'm going to be doing problem 3. And so the problem is f of x equals 1 over x minus 6 minus 2. And so h is negative 6 and k is negative 2. And so since h is negative 6, it does translate 6 right. And then since k is negative 2, it translates 2 down. And so I'm just showing you the parent function without any transformations or anything. And so the coordinates are going to be 1, 1, and negative 1, negative 1. And so next, I'm going to be moving the asymptotes according to the transformations. And so the vertical asymptote is going to be 6 right. And then the horizontal asymptote is going to be 2 units down. So right here, I'm just plotting the points. Earlier, I mentioned how the parent function coordinates would be 1, 1, and negative 1, negative 1. And so I'm just drawing it according to that. And so that means that the points would be 7, negative 1, and 5, negative 3. And so the domain would be x cannot equal 6 because the vertical asymptote is 6, which means that the graphs don't touch, and the range would be y cannot equal negative 2 because the graphs never touch the horizontal asymptote. And so as I just mentioned, the horizontal asymptote would be y equals negative 2. And then the vertical asymptote would be x equals 6. And so these are the horizontal and vertical asymptotes because as you can see, the graphs never touch that line, but they always get close to it. And then next, I'm going to find the y-intercept. And so I'm going to make x equal to 0, and I'm going to plug it into the first equation. So it's going to be 1 over 0 minus 6 minus 2. And then I'm going to simplify that to 1 over negative 6 minus 2. And then 2 times 6 is 12 plus 1. So the numerator would be 13 and the denominator would be 6, which gets us negative 13 over 6. So the y-intercept is either 0, negative 13 over 6 or 0, negative 2.16 repeated. And there is no removable discontinuity because in the beginning we didn't have to simplify, which means we didn't have to cross out any of the factors, which leaves us with no removable discontinuity.